All right, guys, so in lesson 7, we are really getting into the fun part of limits. We are going to start evaluating them. So far we've talked about the numerical way, like the table of values, to look at how to find it from the left side and the right side and using lots of calculations, which can be a little bit time consuming. We've talked a lot about graphing and looking at a graph and either from your calculator or from a given graph and finding the limits. And we are actually going to come back to that in a little bit. But the next part is algebra. And what we're going to be doing is evaluating using factoring and using rationalizing and using all those things that we talked about at the beginning of this learning guide. And so this is the part that's really kind of makes up the majority of your assignment, which is cool. We are going to start off with evaluating here a limit, a basic limit, I guess is what I should call it. What you guys always want to do is, and I'm going to mention this quite a bit, the minute that you can substitute in a value into your limit and evaluate it and actually get a value, you're good to go. You don't have to overthink it. So the first thing that you always want to do is substitute the value into the function. If it works, great, then you're done. If it doesn't work, that's when we're going to have to kind of go back into factoring and that kind of stuff. So let's take a look here. And the one thing that I always look at is my denominator. If I plug in something and I get a 0 in my denominator, then we know that we're going to run into a problem. But if you notice, if x is going to be equal to negative 2 squared minus 1 is not a 0. So let's try substituting it in. So I've got 4 times negative 2 plus 7 over negative 2 squared minus 1. Let's evaluate this a little bit more. Simplify. So I've got negative 8 plus 7 over 4 minus 1, which is just going to give us negative 1 over 3. And because we were able to find a limit just through substitution, guys, we're done, and that's it. Now, do you think they're all going to be this easy? Oh, no, they're not. So let's look at some harder ones. This one is obviously what I was just saying. We're going to have an issue if we have a 0 in our denominator, right? We're going to have to manipulate it somehow. And if we do manipulate it and we still don't get an answer, it could be undefined. So for instance, if I've got any function up at the top or any expression up at the top and I'm dividing it by 0, it's going to be undefined. There's going to be no way of simplifying, no way of doing anything. And therefore we're done. And literally we can say the limit does not exist. The limit does exist if I've got 0 times something. Obviously my limit would just be equal to 0. Or 0 divided by something, again, just can be equal to 0. So 0 is a possible answer for a limit. This is the one that's kind of the kicker. If you plug in a value into your limit and you end up with 0 divided by 0, that's called something indeterminate. And what indeterminate means, guys, is that the door is open for us to manipulate our expression somehow so that we actually end up with a limit. The majority of times, actually pretty much all the time that this happens, you are going to, through algebra, find a limit. Okay, so this is the one that we're going to really kind of focus on. This one, we do need to manipulate to evaluate. Okay, so we've got to do something with that one. So let's look at kind of some steps. And again, you guys can come back to these after you've done some examples and it might make a little bit more sense. So step number 1, always what you want to do, try and take that easy route out. Just like that last example that we did. Substitute the number into the expression first. If you get a value, sweet, you're done. If you get an a divided by 0, so a 0 in your denominator but a function in the top, it's going to be undefined. And again, then no limit exists, so we can say does not exist. This again, step number 2, if I get a 0 over 0, then it's indeterminate, and that opens the door to solve algebraically. So I can either factor and then cancel, or I can rationalize and then reduce. And we'll talk about all of that through these examples here. So let's look at the first one. Right away, if I plug in 5, Again, the first thing that I always tend to look at is my denominator. If I plug a 5 into there, we actually get a value. So we're good to go. Let's do that. I've got my 5 minus 5 over 5 plus 9. Well, 5 minus 5 is 0. 5 plus 9 is 14. Sorry. So 0 divided by 14 exists. Okay, 0 divided by 14 is actually 0. So our limit here is going to be 0. So we could write this out the long way and say the limit as x approaches 5 of our function is going to be equal to 0. Do you have to write that out all the time? No, you can just pretty much give us that number and we'll be good to go. Let's take a look at example number 2 here. This is our limit as x is approaching negative 3. Now again, right away, let's take a look at that denominator. Negative 3 plus 3 is going to give us a 0. But look at the top. I only have a 1 there. So that means I'm not going to get that indeterminate. I'm not going to get 0 over 0. So let's substitute that in and see what we end up with. So 1 over negative 3 plus 3, which is going to simplify to 1 over 0. There's nothing here that we can do. We can't manipulate, we can't simplify, we can't do anything. So simply that tells us our limit does not exist. Now, for those of you that are like, what does that mean, does not exist? How does that look? Well, if you look at the graph of this, okay, and I actually, you could plug that in your calculator if you want, just for the time being, or you could obviously use a table of values to draw this graph. We know that there's an undefined value at x is equal to negative 3, right? We can't have that non-permissible value. And our graph is going something like this and something like this. And again, the question is saying, what is the limit as x approaches negative 3? Now remember the basics of limits. I want to look from the left side to see what it's approaching and from the right side to see what it's approaching. And if it's the same number, we're good. If it's different, that's bad. So from the left side, as I'm approaching this value here, I'm approaching negative infinity, right? Because that's going on forever. If I'm going from the right-hand side, this guy, what are we approaching? Positive infinity. Is that the same? Absolutely not. So because they're different, because they're never approaching the same number, we know again that that limit does not exist. Let's look at some more examples here. This one, now we're going to have to get into a little bit of algebra. And the next few questions all the way up to example 8 are going to be a little bit algebra and rationalizing kind of based. So say to evaluate a limit that involves a rational expression, basically a fraction, you may have to simplify first. So let's look at this guy. Right away, again, just kind of like mental math, if we plug in 4 squared minus 16. So 4 squared is 16. 16 minus 16 is 0. Over 4 minus 4 is 0. This is an example of that indeterminate situation that we were talking about. This means, yes, there is a solution, and yes, we need to manipulate our equation in order to figure out what that solution actually is going to be. So before I just plug in that 4, let's evaluate that, or let's simplify this. So hopefully on the top you can see that this is the difference of squares. So I'm going to have my x plus 4 and my x minus 4. And again, this is going to be, I shouldn't write equals, the limit as x approaches 4. Sometimes I get lazy. And then this is going to be x minus 4. So what do you notice? Well, obviously we can cancel these guys out. This is our simplifying. So now we're seeing the limit as x is approaching 4 of x plus 4. Now go back to what I'm saying. Sorry, I sound like a broken record, but the minute that you can plug in your value and get an answer, you do it, because then you're done. So we're going to do that now. I'm going to plug in my 4 plus 4, and that gives us a value of 8. Let's take a look at the next one. Evaluate the limit as x is approaching 0. Well, right away, if I plug in 0, I have a 0 in my denominator, which is pretty obvious. And 0 plus 4 is 4. The square root of 4 is 2. 2 minus 2 is 0. So again, I have that indeterminate situation. And so now what we need to do is kind of go back in that arsenal of how, we can manipulate our equations. And remember Learning Guide 1, at the very beginning of this learning guide, we talked about factoring, and we also talked about rationalizing. Which one do you think is going to fit into this one? Hopefully you're saying rationalizing, because we do have a square root there. And remember, rationalizing means we need to bring in our conjugate. So I'm going to write this out. The limit as x is approaching 0. I've got the square root of x plus 4 minus 2 over x. What is our conjugate? Well, remember, it's the square root of x plus 4 plus 2. Square root of x plus 4 plus 2. Now, if you have no idea what I'm talking about, you may want to go back a couple of lessons, a couple of podcasts, and rewatch that. Now remember, when we are multiplying by our conjugate, we only have to multiply by the first two terms. So this is going to be the limit as x approaches 0, x plus 4. And then the last two terms, so negative 2 times positive 2, is going to be negative 4. Over, and if you remember me saying a couple lessons ago, do not expand unless you have to. So I'm only going to write x times square root x plus 4 plus 2. I don't want to expand that just yet because I'm lazy, and we might notice something a little bit later. Now let's simplify. Obviously, I have a plus 4 minus 4. That's going to cancel. And when I do that, something's going to be a little bit clear as well. What else can I simplify here? Well, the x's can definitely cancel. So now we're left with the limit as x is approaching 0 of 1 over the square root x plus 4 plus 2. Now once you get to a stage where you kind of pause, remember to check, can you plug in that value of x and get a value? Yes, absolutely you can here. So we're going to plug in our 0 plus 2. And that's going to be equal to 1 over. I've got 0 plus 4 is 4. The square root of 4 is 2. So I've got 2 plus 2. So our final answer there would just be 1 over 4. This is fun, right? All right, number 5, the limit as x approaches 0. Again, just mental math. Plug in your 0. 0 plus 0 divided by 0. Again, you're going to get 0 over 0. Indeterminate, that tells us that we can factor or rationalize or simplify somehow. Well, let's take a look at the top there. Obviously, we can factor out an x. So I'm left with x plus 1 over x. What do we notice? Cancel that guy, cancel that guy. So this is the limit as x approaches 0 of x plus 1. The minute I can plug in that 0, we can definitely get our answer. That's a pretty easy one. Number 6 is a little bit longer than obviously number 5 because we've got lots of factoring that we can do. And again, hopefully you just look at this and you identify, yes, I can factor. If you plug in your 3, again, you're going to notice you've got that 0 over 0 situation. So let's look at how to factor this first of all. Now the top one is nice and easy. I love these. This is a difference of squares. So this is our limit as x approaches 3. I've got x plus 3 and x minus 3, right? So that's a nice easy one. On the bottom, we've got our 3 terms. And remember, we do actually have an a value here. So this is where I need to multiply 2 times negative 5. I get negative 30, and I'm looking for the factors of 30 that add to give me negative 1. That would be negative 6 and positive 5. So with the PSA2 method, that means that I have to rewrite my equation. So I've got 2x squared minus 6x plus 5, x minus 15. Remember, we just cut that right in half, and I factor my first two terms, which is 2x, and I'm going to be left with x minus 3. On this side, I always just bring down that sign, and what can I factor out? Obviously a 5, and I'm left with, again, x minus 3. These guys are the same, so I've got x minus 3, and then it's multiplied by whatever's left over, which is 2x plus 5. Okay, now we can rewrite it, so I'm going to put in my x minus 3 and 2x plus 5. And this is a good thing because you start to notice that we can actually cancel some stuff out. X minus 3 and x minus 3. So I've got limit as x approaches 3 of x plus 3 over 2x plus 5. Now remember, my broken record speech here, you always plug this in as quick as you can. So the minute I can plug in a 3, we're good to go. So I've now got 3 plus 3 over 2 times 3 plus 5. 9 over 6 plus 5 is going to be 11. So we know that, 3 plus 3 is 9. Who's doing this math? 3 plus 3 is 6, and then 2 times 3 is 6, plus 5 is 11. So we've got our 6 over 11, and that's going to be our final answer there. So a couple more, and again, guys, I'm just going to remind you, try these yourself. Don't forget to pause me every now and again, try these, and then just check your answer, because that's really the way that you're going to learn, not just listening to me drone on. All right, so number 7. Again, if I plug in my -3 right away, which is that x is approaching -3, right away you're going to notice a problem. We're going to get our 0 over 0. Now, this one always kind of stumps students because you have a fraction in a fraction, and that's not always an awesome thing to have. So there's ways of manipulating this, and what I would really suggest you do is take out fractions in fractions just to make it look a little bit nicer. So what I would probably do is take that and multiply it by 1 over 3 plus x, just to make it look a little bit more linear. And then really the only thing that you can do, I mean, you could go ahead and multiply each term and go that way, but again, it's going to be a little bit more time consuming, and you're just going to have more fractions, which eventually you're going to have to simplify anyway. I would probably, if I were you, simplify this first. And remember, when you add fractions, you have to have that same denominator. So this is, again, just going to become x approaches -3. Our common denominator would just be 3 times x, which would be 3x. And then obviously, what am I multiplying to the first one? I need to multiply an x. So I'm be left with an x. Plus, I'm multiplying by a 3 on the second one, so it would be x plus 3. And then multiply these fractions together, 1 over 3 plus x. And the cool thing is that before we start to, maybe simplify, like multiply out our fractions, you can take a look and see that things are common. I've got this in my numerator and this in my denominator. They are exactly the same thing, which means I can cancel them out, which is awesome. So now we're going to have the limit as x approaches -3 of 1 over 3x. Now remember, the minute that I can plug in that value, we're good to go. So I've got 1 over 3 times -3, which would be 1 over -9. And we've got our answer there. This one's a little bit trickier, but we're going to deal a lot with fractions in the next few learning guides. All right, now the last one here, when you look at this, again, you kind of want to identify, well, for sure, if I plug in the 2, I'm going to get 0 over 0, so we've got to manipulate. You can probably already tell that just by looking at it by now. Also, what you want to look at is figure out, okay, well, what can I use here? Now, obviously, the top there, we can factor. That's a PSA 1, which is nice. Now, the bottom, I've got a cube minus a cube. And I'm going to ask you to refresh your memory back from, I think it was even lesson 1. We're looking at the difference of cubes here, and there is a formula that you guys can actually use. Remember, where we are looking for our A and our B value. So this one is a good question. And again, normally when we factor, we're going to be able to cancel some things out. This one's going to take a little bit of room, so I'll just erase that. All right. So the first one here, okay, like my numerator, again, I'm looking for the factors of -8 that add to +2. So obviously we can have +4 and -2. So I'm going to say the limit as x approaches 2. I've got x plus 4 and x minus 2. That one's nice and easy. Now the next one, difference of cubes, remember the first thing we need to do is find our a value and our b value. And remember that that is the cube root of the first term and the cube root of the second term. So obviously a is going to be equal to x and b is going to be equal to 2. And remember that formula, it is on your formula sheet. It's basically a minus b times a squared plus ab plus b squared. So if I do that, I'm going to have x minus 2 times x squared plus 2x plus 4. Now this is always good. It's my favorite part of math. Woohoo! They cancel out. So I've got limit as x approaches 2, x plus 4 over x squared plus 2x plus 4. Now in this case, you'll notice there's no more simplifying that can be done. I can't factor that denominator. But what I can do is plug in that value of 2. So let's do that. I've got 2 plus 4 over 2 squared plus 2 times 2 plus 4. And when you evaluate that, you're going to get 6 over 12, which would just simplify to a half. What I really suggest you do, guys, obviously, is practice this. It is a big portion of your assignment and obviously on your test. So make sure you're going through that. You can check your solutions with the virtual classroom. And as always, go to the help desk if you have any questions.